2,000 years ago, Roman philosopher Lucius Seneca famously said in a letter to a friend that we learn by teaching. Fast forward to the 21st century, and Seneca's idea has led to the birth of a new type of agent, the teachable agent. Teachable agents are computer agents whose aim is to help students learn through the learning by teaching approach. Rather than taking on the classic role of a teacher and spoon-feeding knowledge to learners, a teachable agent is designed as a naive learner who instead needs to be taught. While research has shown that students gain many benefits through the use of teachable agents, one common weakness identified in current teachable agents is their lack of proactivity when interacting with students. In order to tackle this issue, we have integrated goal orientation capabilities into our teachable agent. A goal-oriented teachable agent is able to choose and achieve its goals autonomously. Directed by its goals, the agent is able to proactively initiate interactions with students. In our case, the goal-oriented agent has two goals: encouraging the student to teach the agent and establishing a close emotional tie with the student. In order to model a goal-oriented teachable agent, we make use of the GoalNet system. In this system, a goal refers to a state that the agent wants to achieve, while a transition defines how a goal can move from one state to another. A GoalNet describes the goal of an agent in a hierarchical manner. Goals within a GoalNet can be further divided into multiple subgoals. Agent goals and subgoals can be easily created even by non-programmers through the GoalNet designer. For example, we can demonstrate the design process by drawing the GoalNet diagram for the goal to be taught. This goal is triggered when the student approaches the teachable agent. First, the agent requests help from the student. Once the agent obtains a positive response, the system chooses an appropriate learning panel. Based on the student's learning status, it will select from a range of easy to difficult panels. The system omits contents which have been taught already and sets a high priority to content for which mistakes were made previously. Once the student has taught the agent, the knowledge will then be recorded in the teachable agent's knowledge base. We can also use a GoalNet to control a teachable agent's emotions. By evaluating the teachable agent's knowledge base and current status, the GoalNet system is able to generate not only the required emotions, but also their appropriate intensities. Our effective goal-oriented teachable agent has been implemented in a 3D virtual learning environment called Virtual Singapura, which provides secondary school students in Singapore a culturally familiar environment to learn about science. In order to learn about diffusion, osmosis, and active transport, students in Virtual Singapura are able to visit exotic locations such as the roots of a banana tree. In these locations, our teachable agents are seamlessly integrated into the environment in the form of water molecules. Through the use of the multi-agent development environment, also called MADE, our system is able to update and interpret GoalNets during runtime. This allows our teachable agent to carry out the appropriate action within the 3D virtual world in order to pursue its predefined goals. We have designed different learning panels for students to use, such as drawing a concept map to help students master basic concepts, sowing a knowledge seed in the knowledge farm for students to learn more examples, and doing an experiment in the laboratory to allow students to apply knowledge transfer. We have already deployed the system in a number of secondary schools in Singapore and have also gone through many test cycles utilizing both formative and summative assessments. Based on our experiments, a goal-oriented teachable agent improves the student's teaching experience. Compared to the use of traditional teachable agents, the students spend more time on teaching tasks, they complete a larger number of tasks, and they display better learning outcomes. Another advantage of our approach is that because the GoalNet designer and MADE are both consistent with object-oriented design, our agent model was easily integrated into Virtual Singapura and can be easily reused in other projects as well.